Welcome students to another lesson. In this lesson, we'll discuss spherical mirrors. So what are spherical mirrors? A spherical mirror is a reflecting surface. Let us suppose we consider this particular part. Okay, this particular part is reflective in nature. So a spherical mirror is a reflecting surface which forms the part of the hollow sphere. So in this picture, this particular part, this part, fine. This particular surface forms a part of this whole hollow sphere. So now your spherical mirrors are of two types. The first one is your convex mirror. When the reflection takes place from the outer bulb surface of the reflecting surface. In that case, such mirrors will be known as your convex mirror. Now, let us consider, suppose your light is moving in this direction from left towards right. So the light moves in this direction. After reflection, it moves in the opposite direction. But what is happening in this picture is that the light is being reflected from the outer bulb surface of this reflecting surface. So such kind of mirrors are known as your convex mirror. This is the example of a convex mirror where the reflection is taken from the outer bulb's surface. Next is your concave mirror. When the reflection takes place from the inner part of the hollow sphere, right? From this inside part of the hollow sphere. In that case, such mirror will be known as your concave mirror. Now let us take a look at this picture. Suppose this is your reflecting surface. Again, my light is moving from left to right. After reflection, it will move back in the opposite direction. So in this case, what is happening? The light is being reflected from the inner part of the hollow sphere. So such mirror are known as your concave mirror. This is an example of a concave mirror. To have a better understanding of a convex and a concave mirror, let's take a help of a spoon. Suppose if we look at our reflection from the inner part of the spoon, as in this case, when we are checking our reflection from the inner part of the spoon, what happens? A image is formed. Fine. This is the image formed by the inner part of the spoon. So in this case, the inner part of the spoon acts as your concave mirror. Now when we check our reflection from the outer surface of the spoon, like in this case, when she is checking her reflection from the outer surface of the backward surface of the spoon, from the back of the spoon, in that case the spoon acts as your convex mirror. She is checking her reflection from the outer bulb surface or the back of the spoon. Fine. So this, in this image, this is your convex mirror. So what happens in your convex mirror? You check your reflection from the outer surface, or your bulged surface. And this is a image for your concave mirror. When we check our image from the inner surface of the spoon, when we check our reflection from the inner part of the hollow sphere or inner part of the spherical mirror, in that case Such kind of mirrors will be known as your concave mirror. Next, we'll discuss some definitions in connection with the spherical mirror. So, first, let us define pole. The pole is the middle point of the spherical mirror. Suppose this one is your hollow surface and this part is your reflecting surface. So, which kind of mirror is formed by such case? It will be a concave mirror. Fine. Now, the pole, this point, which is denoted by P, will be the center of this reflecting surface. Similarly, for your convex mirror, this is the reflecting surface, the outer bulge surface of this hollow sphere. Fine. This is your convex mirror. Now, the center of this convex mirror, this point, which is denoted by P, is known as your pole. Next, let us define radius of curvature. So, what is the radius of curvature? It is the radius r equals to PC of the sphere of which the mirror forms the part. So, in this image, this is the reflecting surface which is a part of this hollow sphere. And since this is a hollow sphere, therefore it will have a radius. And this distance which I have drawn with the red is known as your radius of curvature. This is the radius of the hollow sphere. Fine. And this radius, this distance, the distance between the pole and center of curvature, this distance is known as your radius of curvature. Similarly, for your convex mirror, this distance, the distance between the pole P and the center of curvature C, is known as your radius of curvature. Fine. This distance is the radius of curvature. Similarly, this distance is the radius of. Next, we'll define center of curvature. So what is the center of curvature? It is the center of the sphere of which the mirror forms the part. So if this is a hollow sphere, then a hollow sphere must have a center. Fine. And as we know, the reflecting surface is a part of this hollow sphere. Therefore, this point C will be known as your center of curvature for your concave mirror. Similarly, in this case, for your convex mirror, center C will be known as your center of curvature for your convex mirror. Next, we will define principal axis. So, a line which passes from the center of curvature and the pole. Can you see this black line? This line is known as your principal axis for your concave mirror. Similarly, the line which passes through the pole and the center of curvature is known as your principal axis for your convex. Now let us define principal focus. When a narrow beam of parallel lights, in this case, suppose this is one light, this is another light. Now these two light rays, can you see? They are moving parallel to each other and they are moving from left towards right. Or I'll say they are moving from, let us say, from west towards east. Fine. So when a narrow beam of light when a narrow beam of light parallel to the principal axis. These beams of light are moving parallel to your principal axis. This line, which is at the center, is your principal axis. When a narrow beam of light moving parallel to the principal axis, can you see? After reflection passes through a point. Suppose let us consider the ray from this point A, which is and this is your object. This AB is your object which is placed at infinity. Okay, very far. Let us consider this object is placed very far away from this mirror. Fine, from this concave mirror. So let us consider a ray coming out of point A and another ray which is coming out of point B. Both of these rays are moving parallel to each other. Also, they are moving parallel with respect to the principal axis. Fine. Now let us consider this ray which moves parallel to the principal axis. After reflection, it passes through a point F. Similarly, the ray which starts from the point B moves parallel to the principal axis after reflection passes through the point F. Now, this point F is known as your principal focus. Fine. So, a narrow beam of light parallel to the principal axis converging to a point. Can you see? First, they are moving parallel, but after reflection, they are moving towards this point F. So, I'll say they are converging towards the point F. So, when a narrow beam of light moving parallel to the principal axis after reflection converges to a point F on the principal axis. This point F is known as your principal focus. The similar case for your convex mirror. Again, let us consider an object AB which is placed at infinity. That means very far away from this mirror. Fine. So let us consider the rays. These are the rays. Fine. They are moving parallel with respect to each other and they are moving parallel with respect to the principal axis. Fine. So when a narrow beam of light moving parallel to the principal axis after reflection diverges from the point. Okay. Now let us look at this point ray. This ray is moving parallel to the principal axis. Now after reflection, it moves in this direction. Fine. Similarly, consider one more ray. This ray is moving in this direction. After reflection, it moves in this direction. Fine. Similarly, your third ray, after reflection, it moves in this direction. And finally, your fourth ray, after reflection, in this direction. Fine. Now, forget about this incident ray, the rays which are moving from west to east. Let us consider only the reflected ray. This one, this one, this one, and this one. Fine. Now, if I extend this line, can you see what happens? They appear to be coming from this point F. Okay, they are appearing to be coming from this point F. So I'll say they are diverging from this point F. Fine. So when a narrow beam of light moving parallel with respect to the principal axis appears to diverge from a point, then this point F will be known as your principal focus. Fine. This is your principal focus. Now, one more important thing is that in case of your concave mirror, the rays are actually coinciding, or let us say they are actually intersecting after reflection. Fine. But whereas in the case of a convex mirror, are they actually intersecting at this point F? No. Fine. So from this also we can categorize this principal focus into two categories. When the rays appears, or when the rays intersect, or when the rays converge to a particular point F, then in that case we will call it as real focus. Fine. But in this case when the rays appear to be coming out of this point F, they are not actually intersecting. Okay, they appear to be intersecting, but they are not intersecting at this point. So in this case I will call this one as virtual focus. Fine. So a concave mirror has a real focus, whereas your convex mirror has a virtual focus. And what is this focus? This focus is the point where the rays appear to. Next, we'll discuss focal length. So what is a focal length? It is the distance f equals to pf between the focus and the pole of the mirror. So let us consider for a concave mirror. In this case, this point is P, this point is F. Now the distance between the point P and F is known as your focal length, and it is denoted by small f. So this is your focal length for the concave mirror. Similarly, for the convex mirror, the distance between the pole P and the principal focus capital F, this distance is known as your focal length for the convex mirror, and it is also denoted with small f. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So thank you.